Okay, so all of you, have you got all of you got your groups?
Yes, madam.
Anybody didn't get your group? Yeah. Mana Farhana tu? Is it here? With
We still have one more vacancy. We decided to go for 4 person in the group. For now, we just have 2 sisters and 1 brother.
Okay. So you decided to mix as well. I give you option, and you decided to add the brother, sister. So who's in your group?
Only one brother in our group.
Me, madam.
Who are you?
Haris.
Siapa?
Haris.
Muhammad Haris bin Faisal.
Yeah.
Okay. So since a mixed group, I will mark more strict. So you should do a better job. Because I don't like mixed group. So since you still want to do it, it's okay. Then you need to do a good job, better job than others. Okay, so so everybody got the group. Now let's divide the what do you call it? The assignment. Who's getting what? Macam mana nak bagi ni? Anybody has idea? Any idea how to distribute so that there's no favor or bias? Okay, so we have 4 groups. We are still having 4 groups, right? So okay. Okay. I will share my screen now. I made this wheel of names just for fun. See. Can you see my screen?
Yes.
Okay. So the first group.
Yes.
Who will be the first group will go to who's Anas, since Anas gave the first full member. Okay, Anas, your group. So I will just spin, see which one you got. So one that's spinning, click to spin. So it won't be biased. Okay, Anas, you are lucky. You got one of the easiest. So so LEDs, Anas, are you listening?
Yes, madam.
So you got your group supposed to present on light emitting diodes. Okay. So whose group is next?
I think you can remove the LEDs from the list first. It's much easier.
Oh, betul. You're right. Good. So whose group next?
My group.
Who are you?
Muhaimin.
Muhaimin? Okay, Muhaimin. So group Muhaimin, let's see what you get. So you got photo detector. Okay, photo detector also not so difficult. So congratulations, it works in reverse bias. Okay, whose group's next? So we only have one more, and the last group will get the last part. And laser is the most difficult. So whose group next?
Our group madam, Munira.
Okay, Munira. So congratulations, Munira and the group. You got solar cell. So remember, write down, because I will not remember which group do what. So you have to remember what your group need to do. And finally, the group with Farhana, Afiqah, and siapa tadi tu? Can't remember the name. Haris ke? Haris. Your
yes,
group,
madam.
your group is on laser. So please do a very good job on laser. Okay. All right. Okay. Any question on the assignment? So I already explained the last class what required inside the assignment. What you need to cover. And I also put the rubric of the presentation in the folder, in the slides folder. If you open there, then you will see the rubric and how we mark the presentation. The presentation it should be with slides, and you should email me the slides. I will give you a Google form for you to upload your slides before starting on the presentation. So it will be 2 weeks from now. So any question for your assignment? There is 30%. It's a lot. So, and from my past experiences of how many years teaching this course, normally the student don't do very well because they didn't consult me. They think what they did was enough, and it's not enough. And they think what they did was right, and it's not right. So my advice to you, if you want to have good grades, to consult before if you already present, I would just say, okay, that's it, accept. Maybe you get 50%. No discussion, finish. Right? Because it's your fault for not consulting. I give this warning every time, every semester, and interestingly, every semester student didn't come to consult, so terimalah apa-apa sahaja markah yang saya bagi. Okay, so it should, and then because sometimes student misunderstood when I say parameters, the student choose parameters which are not relevant to the device. So because if you search in the internet, in the books, there are like millions of things which you may think it's related, but it's not. So the best is for you to consult first. Okay. Alright. So ada soalan?
Not for now.
Okay, not for now. You will have your first quiz Monday. Not Monday, Tuesday. We will take the class time. I don't know how to do it. Should do it or not. It will be closed book. So I will depend on your integrity and honesty not to open any notes and Google or discuss with your friends. If you do, I cannot see, I don't see, but Allah sees. I will make dua. So those who cheat, you will not be successful in this world or hereafter if you dare do that, right? So if you dare cheat, then it's okay. I have Allah with me. So if you cheat, you answer to Allah, and my dua is for you to be, for Allah to punish you in this world and hereafter. So if you have iman in you, you will not do it. Okay, so I will trust you. So because I also trust Allah, Allah will defend on my behalf. Okay, so your quiz will be next week. You will be covering everything that I have taught from the beginning until today. Okay, so everything from the beginning until today. Not including the PN junction. Banyak sangat lah. I think if excluding the PN junction. All the basics, yes. Including today we'll cover some basics. But the PN junction, the energy band diagram, not yet. Maybe I'll give another quiz on that. Okay, so we'll give you on Tuesday. So maybe we will end the class early, then so that you can do the quiz. Okay, so then you can do the quiz and then you can upload your answer. I will give you a Google form for you to upload the answer. Then I can mark it. Boleh. So prepare for your. So there will be only maximum. I'm thinking only 2 quizzes. If kalau saya rajin saya buat 3 lah. Okay, it depends. Biasanya first one ni biasa student buat teruk. So that's why bila teruk sangat tinggal 2, tinggal 1 je. So we'll see. If you are doing good for the first one, maybe you only have 2 quiz. But if you screw up the first quiz, then we need to have 3 quizzes. You suffer, I also suffer. You suffer, you have to study. Me suffer because I have to mark, right? Okay, so we'll see. So hopefully, my hope is all of you, majority of you will do good. So we work on the majority. If the majority is doing good, we only have 2. Only 1 or 2 screw, then I'm really sorry. Who asked you? Why didn't you study? But if the majority are not able to get to answer properly, then we'll have another extra quiz. Boleh. So please prepare for your quiz next week. Now, before we start, I want to share with you this hadith. Can you see?
Yes.
Okay. Somebody, can you please read the Arabic of the hadith? Nobody know how to read? I am student. Yeah. Nobody? Peliknya.
I can.
Who are you?
Afiq.
Afiq. Okay, tafaddal Afiq.
Inna Allaha la yanzuru ila suwarikum wa amwalikum wa innama yanzuru ila qulubikum wa a'malikum.
Can you read the English translation?
Verily, Allah does not look at your outward form appearance, nor at your wealth, but He verily will look into what is in our hearts and deeds.
Okay, brothers and sisters, this is a very important hadith and reported by Bukhari and Muslim. It means it's sahih. So as a Muslim, mu'min, if you believe in Allah and His Rasul, we have to believe this hadith. Hadith sahih, wajib to believe. So what does the Prophet Muhammad SAW said in this hadith, and which a lot of us nowadays in the akhir zaman we do the opposite of this, and that's why the Prophet gave the hadith to us. Inna Allah, verily, for sure, and indeed, Allah la yanzuru, Allah doesn't look at your suwarikum. Suwarikum is your face, your outwardness, your appearance, your clothes. Is it branded or no? Nowadays students like to wear branded clothing, branded handphone, iPhone. You want to look, have certain, I don't know, even tudung pun you want a branded tudung. But the Prophet says Allah doesn't look at that. Allah doesn't look at your appearance at all. Whether you are fat, you are thin, you have a lot of acne on your face, it doesn't matter. It doesn't matter to Allah. And Allah doesn't look at wa amwalikum. Allah doesn't look at your wealth. You are rich, you are poor, doesn't matter. But for human being, dia ni kaya. She's driving a kereta apa yang best sikit?
Tesla.
Oh, Tesla. Ada ke kawan-kawan pakai Tesla? I mean,
Tak ada.
senior ke apa ke, So maybe you when you go out, now you will start comparing. You'll be working and say, oh, this maybe Honda Accord ke, or Honda Civic, starting to work. Asal baru kerja tak mampu Tesla lah, I think. Maybe you were thinking, oh, that one, your friend will have Honda Accord Honda apa Honda Accord ke macam tu lah. So and we compare about wealth. How much salary you get? Which house do you stay? Do you stay in a big house, or you feel shy that you're actually staying in a small house with your family? But this hadith is very clear. In what's important is in the sight of Allah. It's not the sight of the human being. We normally we care very much about what people think about us. Or maybe I feel depressed because I'm fat. Allah doesn't even care whether you're fat or you're thin. What does Allah care? And why do we need to why do we need to care what Allah thinks of us? Because Allah is the one who going to take care of us. Allah is the one who going to protect us. Allah is the one who's going to give rizki to us. So if Allah has a good view on us, you will have a good life in this world and hereafter. But if Allah doesn't have a good look on you or good impression on you, then you have trouble in this world and hereafter. So what does Allah look? So Allah say it doesn't matter what you look like. How's your hair? How's your tudung? How's your nose? How's your skin? Whether you're rich or you're poor, what laptop do you use? But wa innama yanzuru ila, but indeed Allah will look at qulubikum. Allah will look at your hearts. How good is your heart? Your heart pure? Are your heart full of ikhlas? Are your heart full of sincerity? If your heart is clean from bad thoughts and bad impression of others, so Allah will look at your heart. Heart is very important. Outwardness we can see, oh, you look very nice, pakai jubah, songkok, serban. But Allah doesn't care. You understand that? Allah doesn't care. Of course, to cover the aurah, yes, this is what Allah asks us to do. But Allah wants to look in our heart. Why are you covering your aurah? Because Allah knows in your heart you're covering your aurah because you want Allah's redha. You want Allah to be pleased of you because we are slave of Allah. Then Allah can see in your hearts why actually you are praying 5 times a day or you don't pray. So Allah will look at your hearts, and as a human being we cannot look at your heart. I don't know whether you are sincere or not learning, coming to IIUM, to my class, but Allah knows. And Allah will look at your hearts. Wa a'malikum. 2 things that Allah will look. Number 1 is your heart. Number 2 is your deeds, your amal. What are you doing? So sometimes say, oh, I'm a good person, madam. My heart is pure. So what have you done? If your heart is pure, why don't you pray 5 times a day? If your hearts are pure, why you steal? If your hearts are pure, why you cheat? If your hearts are pure, if your hearts are pure, why don't you do a lot more good deeds? So, brothers and sisters, this is a very important hadith for all of us. It doesn't matter what clothes you wear, what house you stay, how much money you have in your bank. It's not important to Allah. And what's important to Allah is what's in your heart and what you have done. So let's strive on to cleanse our heart, right? And also to perform as much as possible good deeds. And I'm telling you this because when I talk to students, many of you and many not you only, anybody in the world, my friends, all these people, we are staying in this world because we see this world. We see with our eyes this world. The akhirah you cannot see. You need to see with your iman. The akhirah you can only see it with your iman. And when you want to see with your iman, your heart needs to be pure. You need to cleanse your heart in order to see clearly what's there in the akhirah. So because we are staying in this world, people are all around us are asking, wow, where do you go for holiday last month or last week or last semester? you'll be asking, oh wow, look at that car, very nice. I'm sure he's successful. Just looking, and you really want that car. So it's not wrong to have to wanting to have that car, but shouldn't we look at people who are, what do you call it, soleh and soleha, and want to be like that? Why do we want to chase the dunya while what's more important is the akhirah? We chase the dunya, we do the dunya. If we chase the akhirah, the dunya will chase for you. This is what the Prophet says. So if you go for akhirah, definitely Allah will give you the dunya, brothers. This is a promise from the Prophet. Tapi how many of us do that and believe that? Okay, so it's a muhasabah for all of us. Why you're here, what you do, why you're here, and what's important for you. Is it important for you what people think of you, or what's important to you? What Allah sees of you. Okay? All right, so now let's go back to semiconductor. Anybody wants to comment or add to my tazkirah just now? Ustaz di UIA, Ustazah di UIA. You're all Ustazah, right? No? When you go out, you know, brothers and sisters, people will look up on you. They will ask you to become imam. And, you know, I have a friend, you know, we lecturers, we don't even study in IIUM, but Allah has chosen us to teach here. It doesn't mean that we have a lot of Islamic background. So Allah has chosen us to be here. But it's our responsibility to learn Islam while being in IIM and teaching you. So I have a friend who graduated in other universities, and one day she went back to she dia dah kahwin, and then in her neighborhood, and then somebody died, and everybody said, oh, she's the lecturer of IIM, push her to, you know, mandikan mayat tu, and then so that she has no idea, she ketar-ketar because everybody, the whole village are pushing her so to do that. So, you know, having the name IIUM, International University Islam Antarabangsa, you know, all of you, people will look up at you balik kampung. So you should have a good akhlak, good iman, good heart, good amal, good amal. So they will say, oh, bagus sudah UIA. Right? You'll be the ambassador of IIUM when you go out. So please upgrade yourself to become better. You know, while you are in IIUM, Allah has chosen you. Upgrade yourself. Learn Islam. Okay. So we'll share my screen now.
Madam,
Yes.
Syed Zarif want to join.
Apa benda?
Syed Zarif nak masuk. Tadi dia request, dia cakap.
Jadi, saya nak kena buat apa?
Tak, bagi tahu je.
Syed Zahra nak masuk je lah. I don't understand. Ke saya tak bagi dia masuk?
Dia tak boleh masuk.
Tak ada pun nama dia dalam the waiting ni. So ask him to...
Sekejap, saya suruh request lagi sekali.
Nanti suruh dia message saya dekat hujung kenapa dia datang lambat.
Okay, madam.
Kalau dia lupa untuk message saya potong markah assignment dia. Oh, I have 5% to play, right? Dia 5% on the akhlak, I will cut dah 0 terus. So I don't mind if you make mistakes, but you have to apologize. Or you need to have adab if you make mistakes, right? To make mistake is human, but as a human we have to take accountability of our mistakes. Okay dah. Kalau dia nak masuk, suruh dia masuk je. Nanti awak beritahu saya. Sepatutnya dia bunyi ting-ting kalau saya nak kena approve dia.
Okay, madam. Terima kasih.
Sama. Alright, brothers and sisters. Remember last time, I think last class, I thought that I said that we have to cover this. these three. And if you still have questions on the PN junction, you better ask now. When I start moving out from PN junction, then you cannot ask anymore. I mean, you cannot ask anymore in the class because I'll be moving to next is we'll be going to apa nama tu? BJT, bipolar junction transistor. Okay, so in order to understand BJT, you need what's the word? It's fundamental. It's extremely, if you don't understand PN junction, you cannot understand BJT. If you don't understand how PN junction works, you will not understand BJT. Okay, so when I teach you BJT, I assume you already understand PN junction. That's why it's very important for you to what do you call it, to understand and ask me questions if you don't understand. Okay, so there are three things that I want to talk today. The lattice mismatch, quantum well, quantum dot, radiative versus non-radiative recombination. Okay.
DB and DST SEMICON.
Do you want to say something, Syed Saleh? Okay, no. Right, so right, Bismillahirrahmanirrahim. Okay, let's go for lattice mismatch. You know what's a lattice? What is a lattice? Mana semua ni? Are you there?
The way that atom structure is organized.
Can you repeat that again, Afiq?
The way that the atom is organized.
The way the atom is organized. Okay, the structure of it, of the atoms. So that's lattice. Mismatch, okay. What does mismatch mean? So, okay, let me draw this. We talk about homojunction and heterojunction before, remember? So homojunction is when both you can have junctions, you can have one junction or many junctions. So this is just one junction here, okay? And then both of the material in the junction are the same materials are called homojunction. So if both are silicon, it's homojunction. Both of it are germanium, it's homojunction. And we also have heterojunction. Heterojunction is when the two materials are different. Okay. Lattice mismatch doesn't happen in homojunction because you are using the same material on top of another material. You're combining the same material, so you don't have problem of lattice mismatch. You will have problem of lattice mismatch when we start to do heterojunction, and when the lattice constant is very much different. What is lattice constant? Anybody? What is lattice constant? Anybody? Nobody? Lattice constant. Nobody knows.
The distance between the atom.
Yes, thank you, Azimuddin. So lattice constant is the distance between two atoms. So inside the lattice, the distance between atom to atom is called lattice constant. So we will have a problem for heterojunction if we have the lattice constant very much different. Okay, so I will now demonstrate how that's possible. Okay, right. So now, so let's say we have two materials, material A and material B. Material A has a lattice constant which is bigger. So I will draw. So it means if the lattice constant is bigger, the distance between atoms are big. Okay, so that's material A. So let's say material B, change the color to be red. And material B has a smaller lattice constant compared to A. So if we start like this, we start at the same point. Smaller, let's say half of the lattice constant. Okay, this is drawing the atoms. Good, so you have material A, material B. Now you want to make a junction. You want to make a device. So you need to connect the two, which means that now previously inside the same material there's a covalent bond, right? So basically this bond with this, and so on, and this one bond with that. So in the same material, no problem. But now we want to connect two different material together. So what happens? Color apa? Pink pula. Okay, so what happens is you want to connect the material A to material B. So okay, if this connect to that one, the second atom needs to connect to this one. The third atoms need to connect to this one, and so on. So you can see it's getting, the bond will be stretched. Okay, so the stretch, we call it stress or strain. It depends whether it's you have to pull or push. Strain. Oh, silap. Macam mana ni? Strain. Okay, so by having lattice mismatch, you are introducing stress and strain inside the structure, and to the extent, right? So if like this, you can still have the bond, but it's strained, and when it's strained, it will affect the electrical properties or the optical properties. But it can be to a point whereby there's no more there's no more bond. So this one will bond with this one. Okay, so you can see one different color. So you can see 1, 2, 3, 4 of the atoms is not bonded to anything. It's dangling bond, and this will cause what? It will cause defects. Okay, so you can get defects, as I mentioned before. You talk about defects and how the defects manifest in the energy band diagram. So one way of getting the defects by having strain or lattice mismatch. Lattice mismatch to the extent that the bond are broken, and you can have this defect. Structurally, if you look in the structure, if you look in a microscope, you will see cracks here and there. You can Google, you can read the books that I gave in the Telegram. Go and read about lattice mismatch. They will give you photos of the lattice mismatch in the microscope. So, so it will affect the structurally. Structurally means you can see in the microscope, and it will also affect the optical, and it will also affect the electrical characteristics. It means that it will affect the electrical properties, the current, the voltage. It will affect the optical, how much light the device will give out. Okay, so that's lattice mismatch. Any question? Sekejap ni.
Madam,
Hmm.
does the connection between the P and the N junction random, or is it like you just draw? Is the first one for the first one, second, third?
Oh no, it can be anywhere. It can be anywhere, but you need to have reference point when you draw. It can be anywhere, but there'll be a time. So if you start in the middle, you can start in the middle, but in right or left there'll be broken bond, right?
So cannot just put randomly,
Just put randomly. What do you mean?
like the connect first, second with the fifth, or
Oh, cannot. If you want to do that, it's possible, but then there will be atoms that will not be connected, which gives out defects. Because you cannot, there's a certain amount that you can stretch the bond. The bond ini macam it's like a getah rubber elastic. You can stretch it, say pump, it will broke. If you stretch it too much, it will break. So when you break, there's no longer bond there, and there will be defect. Okay. Any more question? No? Okay, then next we'll learn about quantum well and quantum dot. Have you heard about quantum well and quantum dot before?
No.
I'll give you 2 minutes to Google quantum well and quantum dot and tell me what you get. Okay, I'll give you 2 minutes to Google quantum well and quantum dot. Semiconductor, don't go for other things. They are the quantum dot. Organic quantum dot lah, macam-macam lah, you know. We want semiconductor, quantum well, and quantum dot. Okay, go and Google it now. Let me know what you get. I will ask you. Finish? Dah habis ke 2 minit? Okay, I will send you into groups. I want you to discuss what you get about quantum dot and quantum well. Then after that, not your own group. This is the automatic random group. I don't know who will be in what group. Okay, and you have a discussion there. Then we will, what do you call it? Then I will, you will need to explain what the group got out of it. Okay. Sekejap. Okay, then trying to Mirza, sisters ke brother? Mirza Ashraf. Mirza, are you here?
Brother.
Oh, brother.
Yeah.
Okay. No, because I got there's another class, you know, the name Mirza but sister. Dia ada Mirza Azhar, Mirza Ashraf. Dua-dua brothers eh?
Mirza Azhar sister.
Oh.
Saya sister madam.
Okay. Apa maksud Mirza?
Anak yang baik.
Masya Allah. Itu menjaga anak yang baik. Okay, so you will go to your own room. Discuss. Are you all in your own room now?
Formed in semiconductors by having material like gallium arsenide sandwiched between two layers of a monolayer electrons.
The problem is with Anas, you have two places. I don't know. Kesian yang tak tahu yang grup satu dia masuk grup mana. So,
Saya dengan grup lelaki lah. Saya pecah dua. Masuk perempuan satu, lelaki satu.
okay, awak beritahu lah grup perempuan awak tak ada kat situ.
Okay, madam.
Okay. So you have like 2 minutes to discuss only. Assalamualaikum. Are you discussing?
Yes, madam.
Okay, you only have 2 minutes. Discuss very fast. What you think, what you get. So Anas will join another group, not this group. Okay. Are you discussing?
Ya, dah.
Dah. So, dah. So you all know what to say. What is quantum dot? What's quantum well?
Quantum dot. Quantum dot. Quantum dot. Quantum dot ni kita boleh cakap kita nak tune dia by the size, by the diameter of the by the size. The larger the diameter of the quantum dot, the smaller the band gap. Manakala
what is quantum dot?
Quantum dot, small spherical nanoparticle.
Okay. What is quantum well?
Semiconductor with small band gap. Normally take place between two relative wide band gap semiconductor.
Awak faham ke?
Dia nak cakap sebenarnya quantum dot ni kita pass elektron dengan spesifik energy, manakala quantum well ni kita transmit elektron, kita ada certain level yang kita boleh transmit elektron. Tapi quantum dot ni dia pass je mana-mana elektron.
Oh, macam bunyi
Dia macam quantum well ni quantum well ni kita boleh cakap yang kita ada certain level je yang elektron boleh pass. Tapi quantum dot ni kita boleh passkan kita cuma just specific elektron, specific energy.
Okay, nanti I will explain. I will go to another room. Nanti later you can explain to the rest. I'm going to other rooms to see. Okay.
Dia biasa guna quantum dot untuk ni lah, untuk solar cell, LED, laser.
Oh. Layer.
Yang lain aku baca aku tak faham.
Cari contoh ada kat mana. Nah, PDF lah.
Aku kat Wikipedia sudah. Search quantum well semiconductor, quantum dot semiconductor. Kalau kau search lebih memang kau jumpa paper.
Agak.
Okay, you have 1 more minute. Okay, see you later.
Quantum dot ni dia.
Kita bagi benda yang sama.
Oh, 2 orang je?
Tadi ada Afika Syuhaimi tu kejap.
Dia keluar?
Masa dia keluar. Mungkin internet dia slow kot macam.
Alright, you have 30 seconds left. Then I will call everybody to join back. Okay?
Madam, do you want the definition of the structure or the meaning of macam transmit electron semua tu?
I want to know what is quantum dot and quantum well. What is it? How does it work?
Oh, how does it work?
Macam mana dia? Apa kelebihan quantum well dan quantum dot ni?
Oh.
Tak ada kelebihan, baik tak payah kita buat dah. Payah nak belajar quantum pula ni.
Alright, we try.
Madam, saya ada jumpa satu PDF.
PDF? You can share the screen if you want later to explain.
Tak nak.
Apa tak nak ya? Explain lah. Dapat pahala.
Dia tajuk dia Quantum Electronic Project, Quantum Well, Wires and Dot and Quantum Well Laser.
Oh, apa benda tu? So, we also want to know what's the benefit of having this quantum well and quantum dot. Still waiting for others to join us. Dia orang tak keluar lagi dari bilik. Awak kat mana tu, Anas?
Mana?
Awak mahalah ke dekat rumah?
Dekat mahalah, madam.
I see. It looks peaceful from the window.
Dah tukar dah.
Alah, tak apalah. What's wrong? Kan nampak aurat pun.
Tak. Biarlah.
Sepa.
Aduh. Okay. So now everybody's here, is it? 16. Kita berapa orang dalam kelas ni? Oh, betul 16. Sebab Anas 2 orang, so jadi 15. So okay. Confuse saya setiap kali tak tahu Anas. Hidup saya ni kena selalu tolak satu. Alright, so now can anybody share what's quantum dot and quantum well? What is a quantum well first?
I can. So basically, quantum well is basically you put a narrow material with narrow band gap in the middle of two materials with a larger band gaps.
Do you have any apa gambar figures to share, to show?
It's like sandwich.
Yeah, sandwich.
Any figures to show?
I think. Let me send the image.
You can share your screen.
Madam, I share the
Yes.
screen.
Okay, you share the screen. Silakan.
Ni Yep.
Okay. So what's quantum well? That's quantum well. What's that figure? Figure 1 is what is the figure 1?
So the figure 1 is basically the gallium arsenide in between the aluminium gallium arsenide. I'm not sure how to pronounce that, but yeah. So the gallium arsenide have a lower band gap. It's shown in the second image, the bottom image. In between, you can see.
So what's the difference of the energy band diagram of a quantum well and quantum dot? Is how's the, so this is the shape of the, you can see this is the quantum well energy band diagram, right? So how about the quantum dot? Do you know?
The quantum dot, I'm not quite clear about that.
Okay. All right. Okay, stop at this figure, Muhaimin. Okay, everybody can see this figure, right? But you cannot see my apa nama, cursor. There are 3-dimensional, 2-dimensional, 1-dimensional, 0-dimensional. Okay, so bulk. Normally when we talk about the homojunction, heterojunction, the normal when we discussed before, all are bulk. B-U-L-K, bulk. Semiconductor. It means that it's 3-dimensional. The carriers, the free carriers can flow everywhere inside the semiconductor. Then you have the so this is quantum dot. Yeah, this is quantum well. This is nanowire. Okay, you have you heard about nanowire? No. These all like big apa nama ni apa kata dia tu macam jargon macam bunyi hebat lah, bombastic words. Quantum dot. If you talk to anybody, oh I learned quantum dot today, they will say wow, what's quantum dot, right? My PhD, my PhD for 5 years was on quantum dot laser. So my life for 5 years, I live and eat with quantum dot and quantum dot laser. That's why those who do lasers, good luck. Make sure you explain it properly. So because that's my my expertise. But LEDs are easier. Before you become a laser, it has to become an LED. So LED is the stage before lasing. So this quantum dot, the zero when it's confined, the word is confined. When the carriers are confined means that the carriers are dia macam tersekat, terkurung. Confined means that terkurung. The in 3-dimensional, it means that here on the zero, the apa nama ni, zero. The quantum dot, in quantum dot, the carriers cannot move. It can only stay at that position. Nanowire, it can go to one direction only. Quantum well, there's 2D. It can move in 2-dimensional. Okay, we are controlling. Remember, we engineers, our job is to control. So we, by making it quantum well or quantum dot, we can control the movement of the carriers. And when we control, we can make wonderful things. So what are the wonderful things? Okay, you can apa nama ni? Stop sharing.
Mana? Okay.
What can you do? What's the benefit of having, where do we use quantum well and quantum dot? Anybody?
Quantum dots. I know that it is being used as a technology for screen, for display.
Quantum well technology for screen?
No, quantum dots.
Technology for screen?
Yeah.
What screen?
Display, for display.
Or is it, okay, is it semiconductor quantum dot? Did you check? Or is it any other quantum dot?
I think it is semiconductor, but I have to recheck.
You think so we engineers, we don't do based on our feelings, and you know, so we need to be facts. And so that I always tell my student, when I did my PhD, my supervisor always he trained me to be very logical and do not use the feeling. So he said, I don't want to hear what's your feeling about, what you're thinking. I want facts and figures. So when you talk to an engineer, we need to be sure whether it's actually quantum dot semiconductor or no.
It is.
Huh?
It is semiconductor.
Semiconductor. So can you share the reference here? Ya, ada button share kat bawah tu. Green button lah. About so what does it say? Is it used in the screen?
Quantum dot display is a display device that uses quantum dots, semiconductor nanocrystal, which can produce pure monochromatic red, green, and blue light.
Yes. Yes, but when you go down there, when it says crosstalk and RGB LCD color, used in LED backlit, they are using OLED. They are not using semiconductor. OLED is organic LED. So this article is mixing between the semiconductor and the the organic LED. And collider quantum dot is not semiconductor. So can you stop sharing? So basically what I'm telling you, be careful. This is what, thank you for highlighting this. So this is the mistake that normally students will do in the assignment. They don't check properly, because that's why I say in internet, there are like millions of things and you need to filter between the millions. So the best is for you to go for textbook, where they put already here one section, another section. You can find in the internet as well, but guided by the textbooks. Okay, so quantum dot screen, yes, but not normally. If you go to screen or like the quantum, if you can buy Samsung, I think have a new technology like quantum dot LEDs screen. They are marketing it that way. I know you Google lah. Saya dengar masa awal tahun pun. So but mostly on OLED, organic LED. However, semiconductor also have quantum dot LED or lasers. So where does it used? So what's the benefit of making quantum well and quantum dot? Okay, question. Do you think it's easy to make quantum well and quantum dot? Easy ke tak? Susah ke senang? Do you know how to make it?
No, I don't.
So as mentioned by the brother, it's a sandwich. It's a sandwich. So now we go for quantum dot. Quantum well first. Quantum well, basically what you mentioned before was right. It means that you sandwich between two larger bandgap and smaller bandgap material. So it must be like this. If I draw, it be like this. You must have, because sandwich minimum 3. Can you have 4? Yes. Can you have 5? Yes. So it can be like this or complicated. You can read more. It can be this A is the simplest. B can be okay. So here material. So I'm just telling you what we can have. So this is a material. So for example, this device A, device B, is X material and Z material. So Z has a smaller bandgap compared to the X material. For the bottom one here, let's say we can have X, Z, X, Z, X, Z, X, Z, X. How many quantum well you have at the bottom here? How many quantum well you have?
4.
Good. 1, 2, 3, 4. Okay, 4 quantum well. So normally you don't have only one quantum well. And quantum dot like have many. One is like negligible. You cannot do much. But let's learn from the one. So I just want to bring that somewhere. Okay. Okay. So let's go back to this one. Okay, so this can be, so where the quantum well can be in a p-n junction. Okay, you learn about p-n junction, right? P-n junction just p and n. So now you have the quantum well. Before we talk about p-n junction, you need to know why we want to have quantum well inside our p-n junction and quantum dot inside our p-n junction, because if you go and read in the textbook and many references in the internet, it will increase the efficiency of the optoelectronic device. Okay, so quantum dot and quantum well is more related to optoelectronic devices. What are the optoelectronic devices, brothers and sisters? Is the 4 that you, for your assignment: laser, LED, solar cell, photodetector. Okay, it's more, if it makes the devices more effective. So how, the question is how does the quantum make it more? If you buy any LEDs now, brothers and sisters, if you go buy any LEDs for your house, any blue LED, any red LED, any LEDs, I will say 60% or 70% of the LEDs that you bought is actually quantum well LEDs. Why? Because quantum well, it makes the LED more efficient and you will see more light coming from LEDs with the quantum well. So how does it work? This is the p-n junction. Basically, normally if you learn, when you do your assignment, you will find out that most of the optoelectronic device, they're not just p-n junction. They are p-i-n junction. What's I? Anybody knows what's I? I is the intrinsic material. So you have P-type material, intrinsic material, N. So the intrinsic is inside sandwich between P and N. Okay, why do we have that? Because we want to increase the depletion region. Why? Because the intrinsic region have very low doping or less on. In real life, there must be, you cannot make pure intrinsic. If you make a p-n junction, it will be either slightly P or slightly N in real life. Theoretically, yes, you can put an intrinsic with have no doping at all. So, so when you have this, what happens is, if you remember, if p-n junction here, at zero bias, you will have what do you call it? Depletion region. Remember, because of the recombination that occurs, you have depletion region. So if you have PIN junction like this, the depletion region will be here, here, and the rest. It will deplete all the I region because I region have no doping or very less of doping, so it will deplete all. So you can see the depletion region become bigger, and it's good for optoelectronic device. So most of it, minimum, no longer people will do PN, they will PIN. Now, where's quantum well? Okay, where are the quantum well? So basically, for PIN, the quantum well will be, will be inside the I region. Draw besar sikit, extreme sikit. So PIN. So normally the quantum well or quantum dot will be inside the I region. So it will be like this. So you have.
No? Yeah. Mahalah Mariam. Okay.
You forgot to mute Farhana. Okay. Then so you'll be recorded forever for the future too. So you'll be in the internet. Okay, never mind. So basically, can you see here? So here I can have 3 quantum well. So I have again if I redraw this quantum well, yang ni, mana quantum well saya tadi? Tak ada dah, hilang. Oh yeah, this one. If I redraw it here, the material, this will be material tadi, X, Z. So X, Z, X, Z, X, Z, X. Okay. And this can be material X doped P, and this can be material N doped N. Okay, so that's where the quantum well and quantum dot will be. It will be the I region, and it will increase and the same as quantum dot. Quantum dot, the difference between quantum well and quantum dot structurally is quantum dot is just thinner. So dia macam ni, dia quantum well dan quantum dot ni dia macam cakap Melayu senang. Dia if I cakap Melayu takut kita ada ke orang bukan Melayu dah ni. To make a semiconductor device is like buat kuih lapis. Anybody pernah buat kuih lapis? Tolong mak dia buat kuih lapis. Pergi tengok macam mana buat kuih lapis. Kuih lapis you start with one layer. Okay, you start with one layer, the red layer kan. Normally you have red, white, merah putih beli kat kedai tu. So you start with one layer, and this is the substrate. Substrate is the one, the lowest, like the foundation where you build the layers for your semiconductor device. Then you grow. Grow means you can bombard molecules to grow. So you have. So you can have this. You put a thin layer. It can be thin or it can be thick. It depends on you. Okay, but normally it will layer by layer. You put atomic layer, they will increase like that, like that, like that, like that. Okay, so let's say this is the X material. So we are referring to this one. So this is the X material. Then you make a very thin layer, a thinner layer of nanometer. Of hundreds of nanometer. The difference between quantum dot and quantum well is the thickness of the layer. So this one, let's say hundreds of nanometer, it will be quantum well, Z material. And then you buat kuih lapis lagi, then you add another layer, bigger bulk layer. Kenapa saya drop situ? So macam ni, another layer of the X material. Then then you get one quantum well. Then you make another layer. So this one So if this is a PN junction, you can do while you are making the Z layer, the X layer at the bottom here, you can dope it to be P. Okay, then you have the intrinsic, then the Z, you have the intrinsic, then you have the Z, then you have the intrinsic layer again, then you have then you can, if you want another quantum well, you add another quantum well. You add another 100 nanometers of the material of Z. Then you sandwich it again. Or material X. And then again, finally, you want to complete the PN junction with the layer X, but now you dope it with N. Dope it. Let's color this with the red. X, tapi with the N, dope with N. So you get your PN junction. Okay, so basically you have two quantum dots inside. So if you have multiple quantum well. If you have multiple of quantum well, later you can add more of the Z. So the difference with this is quantum well. Huh? So how about quantum dot? So quantum dot is just that the Z layer here is thinner. It's in the tens of nanometers. This is for quantum dot. For quantum well, the thickness is roughly 100 or so nanometer. Okay, so that's why they call it nano apa nama? Nano crystal, nano something, because the what do you call it? The thickness is very thin. Okay, any question? So that's about the structure. Kita tak draw lagi energy Venn diagram dia. Any question? Are you with me? Or sleeping or don't understand? Ni paling simple lah saya boleh explain ni. Any question?
Madam.
Yes.
What's the effect of having multiple wells in a single junction?
Okay, good question. In order to answer that, I have to draw the energy Venn diagram, and I need to show how the combination. We learned about generation or recombination before, right? So for optoelectronic devices, for you to get light, for you to get light, or for it to be apa nama tu? For it to be sensitive to the light, you need to have generation or recombination. Recombination for laser and LED, generation for photodetector. Okay, so those who got photodetector, you need to know. So for all of you need to know, understand now. Basically, in the end, the final exam, there will be question on that. So it depends. It's just basic on recombination or generation, and this generation and recombination is affected by the quantum well. So how does it affect? I think we'll go next class because we only have 3 minutes left. Okay, so I will share again before we end. So Anas, remind me next class to answer that question. Boleh? Anas?
Okay, madam.
So we haven't finished the quantum dot and quantum well. In next class, I will draw the energy Venn diagram. And then I will also explain how does the quantum dot and quantum well affect the optical properties. It's more sensitive to the optical properties compared to the electrical. Electrical tak ada, they should be, but there's not as sensitive as the optical. So that's why normally the optoelectronic device, you will see many wants to go to quantum well and quantum dot. However, to make quantum, so you can see to make quantum dot, it needs to be of the very low, very small, very fine thickness. and it's not easy to control the thickness that you put. 10 nanometer, can you imagine 10 nanometer, how big is 10 nanometer? Remember when we watched the semiconductor video just now, hundreds of nanometer is like your hair divided into 1,000. Your single of your strand divide into 1,000 pieces, 1,000 layers. And 10 means even smaller than that, right? And we need to control it we need to control the thickness. If it's more than 10, it will no longer be quantum dot. You can also Google how the quantum dot looks like for semiconductor in a microscope. You can see it. Dia jadi macam islands. Dia jadi dot. Dia jadi interesting lah. So because of the strain, remember we talk about strain, because of the thickness is very small, it lots of strain inside this layer here. There will be a lot of strain inside this layer if it's quantum dot. So what happens when the strain is too high, in equilibrium, it will tend to become like an island. Dia jadi dot. So you can go and Google see with your own eyes why the name is quantum dot. Because when you look in the microscope, it looks like a dot. Ada panggil dia islands. So itulah menarik kan. Dari manusia tu boleh berjaya, alhamdulillah, berjaya make 10 nanometer. Now they can go to smaller than 10 nanometer. It's just mind blowing what the technology able to do now. And hari akhirat Allah kata some sirat, titian sirat tu can be macam rambut dibelah berapa. So sekarang pun kita benda tu ada. So macam imagine macam mana kita nak tampung diri kita dan dosa-dosa kita. Masuklah kita na'udzubillah min zalik dalam neraka. So that's why dunia ni try our best lah, jangan buat dosa. Okay, so I think next class insyaAllah we'll cover the rest of the quantum and quantum well, and we'll talk about radiative and non-radiative recombination. Yang ni we talk, it has to do with the defects, the lattice mismatch, and the optical properties. Okay, ada soalan before we end? Tak ada? I hope you understand. If you don't understand, too bad. I think very sad if you don't understand, because I think this is the slowest that I can go, and at as basic as we can go. So this is the fundamental before you go to other big. If you go to even Infineon, if you want to do VLSI design, integrated circuit, you need to understand the basics, and these are the basics of semiconductor. If you don't understand basics, maybe I don't know, maybe you don't want to join this working in a semiconductor company. Okay, mesti kata apa benda quantum work, itu tak susah pun, it's not difficult. Kalau tak faham, watch the video many times and then ask me. Maybe sometimes I talk very fast, go and watch the video many times and ask me. Tak susah pun, senang je. Okay, let's close the class with a doa by a brother. Who's the brother who wants to do the honor today? Yang tak pernah baca lagi. You know who you are. Ke semua dah baca?
Bismillahirrahmanirrahim.
Okay, Haris, where's your video?
My internet is a bit unstable right now.
Okay. Teruskan.
Allahumma arina haqqa wa warzuqna taba'ahu wa arina batila batilan warzuqna tinabah. Amin.
Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina azabannar. Sallallahu ala sayyidina Muhammad wa ala alihi wa sahbihi wasallam. Alhamdulillah rabbil alamin. Good. Teruskan usaha praktis You know your turn will come again, all of you. So practice, cari praktis. Okay. Nak jadi imam ni nak kahwin, macam mana nak kahwin ni? Baca doa tak boleh ni, brother sisters. Betul dia kena baca doa dengan confident. Betul tak? Kan Nabiha, takkan nak kahwin dengan orang yang baca doa pun tak confident. Ni generally I'm talking about all brothers ah. Tak cerita lagi jadi imam kena baca bacaan kuat-kuat. Mungkin lepas ni kita cek hafazan pula. Kita cek hafazan dalam kelas ni. Tak boleh pas hafazan, saya kata tak payah join lah kelas saya. Mesti ramai or drop beramai-ramai lepas tu. Okay, let's close the class with tasbih kifarah and suratul As. Subhanakallahumma bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Bismillahirrahmanirrahim. Wal 'asr innal insana lafi khusr illa alladhina amanu wa 'amilus solihat wa tawasaw bil haqq wa tawasaw bis sabr. Okay, assalamualaikum warahmatullahi wabarakatuh.
Thank you, madam.
Okay, you're welcome.